All right, so let's talk about the atomic structure. All right, first of all, the atom, which is the smallest part of an element that still retains the properties of the element, but the atom actually can be broken down into three subatomic particles that actually don't retain the properties of that particular element. And what are those subatomic particles? So we have protons, which are positively charged. So we're going to denote that as P with a positive superscript. And they have a mass. They're super, super small. As atoms are already small themselves, they're super small. They have 1.674 times 10 to the negative 24th grams. And that's a mouthful, as you can tell. So we're going to say, instead of writing all this, we're just going to denote that as 1 atomic mass unit, or 1 AMU. The second subatomic particle that we come across is the neutrons. Neutrons are electrically neutral, meaning they are not positively charged or negatively charged. They're denoted with an N with the 0 superscript to denote that. And they too also have a mass of 1.674 times 10 to the negative 24th grams. So we can also denote that as 1 atomic mass unit. And lastly, we have the electrons. The electrons are negatively charged, and we're going to denote that as E with the superscript of a negative. And they're super small compared to the protons and neutrons. They only have a mass of 9.11 times 10 to the negative 28th grams. So basically, it's 1/1840th of the mass of these two. So essentially, it's pretty much weightless comparatively. So we're going to say it's 0 atomic mass units. Okay? So how do these guys play a part in each other, and what do they look like in an atom? Well, if we go to Niels Bohr's model, which is the simplest model to describe what an atom looks like, in the middle we have our protons and neutrons, which are positively charged protons and neutrons. So the nucleus is going to be positively charged. Surrounding the nucleus in orbits, we have the electrons. Electrons are negatively charged, as you mentioned earlier. And so because the atom is overall electrically neutral, the number of protons equals the number of electrons within an atom. And how these guys behave with each other and how they interact actually gives the element its chemical properties and how it behaves with other elements. So that's the atomic structure.